Hello guys, now we are going to discuss some of the important compounds of alkaline earth metal, and in that mainly we are going to focus on the compounds of calcium. Now calcium is a very important, the compounds of calcium are very important because they are used for mainly for construction purposes. So the first compound which we are going to discuss, that is calcium oxide, or it is also called as a quicklime. This is formed by heating limestone so about 1073 to 1270 Kelvin. So at this high temperature, the thermal decomposition of calcium carbonate is taking place, and there is a formation of calcium oxide, that is also called as a quicklime, with the evolution of carbon dioxide. Now this reaction is reversible. It can be made irreversible by removing carbon dioxide time to time. Calcium oxide is actually a basic oxide. So it is a basic in nature. So it reacts with many of the acidic compounds. So calcium oxide, when react with H2O, you will get slake lime, calcium hydroxide, or slake lime or calcium hydroxide. It can react with carbon dioxide so that there is a formation of calcium carbonate. It can react with SiO2 so that it gives you calcium silicate. It can react with P4O10, phosphorus pentoxide, so that we are getting Ca3PO4 twice. It can react with HCl, so that we are getting CaCl2 plus H2O. It can react with H2SO4, so that we are getting CaSO4 plus H2O. It can react with HNO3, so that we are getting CaNO3 twice plus H2O. So these are very quicklime is actually used for various purposes. It is one of the main ingredients in a preparation of slake lime. At the same time, for the preparation of various types of different salts. It can also react with carbon about 2000 Kelvin. Okay, we are getting calcium carbide, CaC2 plus carbon dioxide is evolved. Calcium carbide is a very important compound which is used in the preparation of acetylene. It can react with NH4Cl, ammonium chloride, so that we are getting CaCl2, calcium chloride, plus it gives you ammonia plus H2O. So in a laboratory preparation of ammonia, quicklime can be used. So this is all about the reactions of quicklime. Now we will go for the next type of a compound of a calcium, and that is nothing but slake lime. Calcium hydroxide or slake lime. This is diacidic base because it has two replaceable OH minus ion. So it can be prepared, one of the method which we have seen already. This is the method when as quicklime is treated with H2O, you will get this one. It can also react with calcium chloride. It can also form by reacting calcium chloride with sodium hydroxide, so that a more soluble sodium chloride is formed and calcium hydroxide will precipitate out in that case. So what are the reactions? Again, it is a diacidic base, so it will react with various compounds, like it can react with CO2, so that we are getting calcium carbonate plus H2O. It can react with HCl, being diacidic, it accepts 2 proton, and we are getting CaCl2 plus H2O. It can react with H2SO4, so that you will get CaSO4 plus H2O. It can react with HNO3, so that we are getting CaNO3 twice, calcium nitrate plus H2O. It can react with SO3, so that we are getting calcium sulfate plus H2O. It can react with P4O10, phosphorus pentoxide, we are getting calcium phosphate plus H2O. Okay, calcium hydroxide again react with ammonium chloride also, and we are getting CaCl2, and ammonia gas is liberated along with H2O. Calcium hydroxide can be decomposed if we heat it about 700 degrees Celsius, 700 Kelvin, about 700 Kelvin. It undergoes decomposition and we are getting quicklime. So there is a loss of H2, dehydration is taking place. A very interesting thing about this calcium hydroxide solution is actually a slake lime, or it is also called as a lime water. When carbon dioxide is passed through it, so one of the reaction which you have seen here, so that colorless solution turns milky, and it is because of formation of calcium carbonate. Now, if I am passing excess of carbon dioxide through this, then the solution turns again colorless, and that colorless solution is because of formation of calcium bicarbonate, which is soluble in water. So this is insoluble in water, this is soluble in water. Because of the calcium carbonate is insoluble in water, this precipitate out and that appears the solution milky. Calcium bicarbonate, since it is a soluble in water, that milky solution turns to colorless. Now, if we try to dry this, then you will not get solid calcium bicarbonate, as we discussed earlier that bicarbonates of alkali metals exist in a solid state. Bicarbonates of other metals are always exist in a aqueous solution, and therefore if you try to dry it or if you start heating it, this decomposes to give you calcium carbonate again. So these are the compounds of calcium. Now few more compounds are there. One compound is limestone calcium carbonate, which is a very important in a construction purposes, preparation of various monuments, etc., etc. Now calcium carbonate can be prepared by this method, or rather it is obtained from the mines also. Calcium carbonate is essential in a generation of carbon dioxide, commercial preparation of carbon dioxide, commercial preparation of quicklime, commercial preparation of slake lime. Calcium carbonate, the reactions are similar. It is a salt of weak acid and strong base. Calcium carbonate is a salt of weak acid and strong base. And because of this, it shows almost all properties of calcium hydroxide. Similar properties when it reacts with carbon dioxide, when it reacts with HCl, it gives effervescences, and those effervescences of carbon dioxide. So calcium carbonate solution many times used for the testing acidity of the solution also. Calcium carbonate is sparingly soluble in water, but if calcium carbonate is reacted with any of the solid, reacted with any of the acidic substance, even with the inorganic organic acid, you will get effervescences, and those effervescences are because of the evolution of carbon dioxide. Now, the next one is plaster of Paris. Actually, plaster of Paris is nothing but this is the plaster of Paris. Plaster of Paris actually prepared from gypsum. This is plaster of Paris. It is prepared from gypsum. Gypsum is nothing but 2HCaSO4, 2H2O. After losing H2O molecule, there is a formation of plaster of Paris. If you heat gypsum strongly, you will get anhydrous calcium sulfate. That is also called as a death of plaster of Paris. So that will not work. Again, this plaster of Paris has a strong affinity for water. When it absorbs water, that absorption of water and the molecular arrangement make plaster of Paris hard enough that hardness, becoming of hardness is irreversible. We cannot use that plaster of Paris again. So it is because of that plaster of Paris after absorbing moisture actually converted into gypsum, and therefore it becomes hard. In a cement industry, these compounds, calcium carbonate, plaster of Paris, quicklime, are used as one of the important ingredients along with some of the salts of magnesium, magnesium carbonate, magnesium chloride, etc. So in and all, in S block element, we have studied one part, that is nothing but alkali and alkaline earth metal. Now the next part which we are going to discuss, that is hydrogen. Since in a hydrogen the electron is entering in a s orbital, it is called as a s block element, but the position of hydrogen in a periodic table is not certain. Why is that so? And at the same time, what are the different properties of hydrogen and what are the different compounds of hydrogen which we are using in a everyday life? That also we have to discuss, that we discuss in the next session. Thank you very much.